let's try the 19th one. And then tell me the answer. And when you get the answer right, we will move on to the next. Yes.
Ma'am, 19th one.
Yes, 19th.
Ma'am, it's 1/9.
Okay, so you're saying 19th is A. Right, that's correct, Mridula. Hamna, did you get the same answer? Yes? Hamna, yes or no?
Yes, ma'am.
Okay, good. So next 20. Should we do this together, or you guys can do this yourself? Twenty. If you're not able to understand the question, just ask and we will try to solve this together.
Ma'am, I think it's D.
Ridula is saying it's D. No, it's not D. Yes, Hamna, any guesses, any try?
Ma'am, I guess it's B.
Okay, it's not B either. So let's try to solve this. Okay, 256. Okay, so
Ma'am, it's A.
yeah, it's
It's
A.
A.
So let's, yeah, it's A. Hamna, did you get A? Let's try to do this. Okay, so it is 256 to the power 0 0.16, 0.09. So it is 256. Are you able to see my screen? Yeah. To the power 0 0.16, and that is multiplied by 256 to the power, I think it's, yeah, 0 0.09. So the first thing that we're going to do is we're going to recall, okay, so a to the power m multiplied by a to the power n. So it's the same base, but exponents are different, right? Exponents are different. Same base, exponents are different. So what is this, Hamna? What will this be? Hamna, a to the power m into a to the power n.
A raised to the power m plus n.
Very good. Right, so that's what we're gonna have over here. So it's 256 to the power 0 0.16 plus 0 0.09. And what is that, Hamna? What is this? Yes? 0 0.16 plus 0 0.09. It's 0.25, isn't it, Hamna? Yes?
0.25.
Yeah. All right. So now what you need to do here is you need to write this as sorry. You need to write this as 256 to the power 25 by 100. Okay. Now, Mridula, what will we do after this? 25 by 100.
Ma'am, 20.
Yes. See, 20.
Ma'am,
I'm not able to hear
ma'am,
you.
256 is equal to 2 raised to the power 8.
Yeah. Yeah. Okay. So we'll just change that in a bit. So 25 by 100, we can just cancel that, right? Hamna, is it clear? So Mridula, Hamna, just let me know if it's clear till here.
Yes, ma'am, it's clear.
Okay, thank you, Hamna. So as Mridula said, we can write 256 as 2 raised to the power 8. Let's see, can we really write it as that? So it's 2 into 2 into 2 into 2. So this is 4. So this one is 4, 4, 4, and then 4. So that's 4 for the 16, and then 16. So that's 256. All right. So it's 2 raised to the power 8. Okay, 2 raised to the power 8. And the whole thing to the power of 1 by 4. So what we can do now is 2 to the power 8 into 1 by 4, right? And then this becomes 2 raised to the power, now this is 4 and then 8 gets cancelled. So 2 square and that is 4. Mridula, is it right? Sorry. Yes? Okay. Now let's quickly move on to the next one, 21. And for this, you don't even have to do a long calculation. It's just very simple. 21. Yes. So I think Mridula is having internet issues. Yes, Hamna.
Ma'am, I don't understand the question.
Okay, so the question says which of the following expressions is equal to x? So that means the question says that when you solve each of these options, right? You solve each of these options, which of them after solving is going to give you x? The answer will be x after solving. Which of these? So let's take a look at the first one. All right, let's take a look at the first one. And the first one is x to the power 12 by 7 minus x to the power 5 by 7. So it is, just a sec, right? So the question asks which of these is equal to x. Ridula, we are doing the next question and I'll just show you what the question is. The question is this. Mridula, are you able to see it? Okay. So the first one, which of these is equal to x? So x to the power 12 by 7 minus x to the power 5 by 7. Hamna, is this equal to x? If you solve this, will you get x? Yes? Hamna, please respond. Mridula, am I audible?
Yes, ma'am.
Okay. So the question is, if you solve this, will you get x? Yes or no? Yeah, okay. I'll show you the question again. There you go. It's the 21st question. Yes, Mridula. Did you understand the question? Okay, so I'm just gonna solve it. I think, yeah. Hamna, so Hamna, am I audible to you now?
Yes, ma'am, you are audible.
Okay, so I guess Hamna is not able to. Okay, just a second. Um, all right. So Hamna, if I'm audible, please just let me know what this will be equal to. What do you think? You can unmute yourself, or you can just write it in the chat box. Anything.
Ma'am, it's x raised to the power 1.
Okay, so it is x to the power. All right, it's x to the power 12 by 7 minus x to the power 5 by 7. All right. Now I'm going to take this. This is the first case. And the second case that I'm going to take is x to the power 12 by 7 divided by x to the power 5 by 7. Okay. And there's a difference. If you take this, we know that if we have a to the power m divided by a to the power n, what is this equal to?
Ma'am, it is to the power m minus n.
Exactly. But if we have a to the power, just a sec, a raised to the power m minus a raised to the power n, does it mean it is equal to a raised to the power m minus n? Yes or no?
No, ma'am.
No, it is not equal, right? So therefore we cannot say that this is equal to x to the power 12 by 7 minus 5 by 7, right? So this is wrong. Okay, it is not equal. So the first option was x to the power 12 by 7 minus 5 by 7. That is not equal to x. Now let's take a look at option B. Yes, is option B equal to x?
No, ma'am.
What is it equal to? Hamna, I need responses from you as well. So the second option is x to the power 4, this thing to the power 1 by 3, and the whole thing, like we have a 12th root of the whole thing. So just a minute. Yeah. Okay. All right. So what is this going to be equal to? Yes,
Ma'am,
right?
yes.
And
Yes, ma'am.
this is going to get cancelled with this, and we're going to be left with 3. So now we have x to the power 1 by 9. Is that right, Mridula?
Yes, ma'am.
Okay, now let's quickly see the third option because we need to start a new chapter today. And I was hoping that you people would have done the homework, but okay, never mind. Yeah, this one. Will this be equal to x?
Ma'am, B. Ma'am,
Yes.
ma'am, it's B or not?
Is it B? See, B was not, B was, what was, what did we get after solving B? We got x to the power 1 by 9, but we need x. So it is not the right option. Option B is not the right option. Okay. Is it
Okay.
clear, Mridula?
Yes,
Yeah. So
ma'am.
now we're taking a look at option C. Is it going to be the right option? Is it going to be equal to x? Let's take a look. Okay. So we have x cube and the square root of this. And then we have the whole thing to the power 2 by 3. So this can be written as x cube, right? Whole to the power 1 by 2. And this whole thing to the power 2 by 3. So then we have x to the power 3 by 2 into 2 by 3. Is it right? Ridula, is it right?
Yes, ma'am.
Okay, Hamna, I would appreciate if you also could
Yes, ma'am. Yes,
respond.
ma'am.
Okay, so then
Yes,
these two
ma'am.
get cancelled. Yeah, okay. So this is x to the power 1, which is equal to x. All right. Now let's take a look at the fourth option. X to the power 12 by 7 into x to the power 7 by 12. Will it be equal to x?
Yes, ma'am.
Right, it will be equal to x. Okay, so both of these options are correct. Just a minute. All right. So now let's move on to the next chapter, which is polynomials. Okay, so we have polynomials. So have you ever heard this word before, polynomials?
Yes, ma'am.
Okay, what does it mean, Mridula? Yes, what does it mean? Hamna, do you have any idea? No? Okay. So polynomials, it just means, see, poly. Okay, can you guess what
Ma'am,
poly
it's a
means?
type of algebraic expression.
Very good. Yes, it is a type of algebraic expression which you have studied, like algebraic expressions you have studied in your previous classes as well. So what does poly mean? Does anyone know? Poly means many. Okay. All right. And nomial, it means names. Names. Or in the mathematical sense, it means terms. So do you know what terms means? I think you've studied this in algebraic expressions. Yes? Do you know what is the meaning of term? All right. So let's just first, we'll take a look at what is a polynomial and what is not a polynomial. Okay. So like in your previous classes, you've taken a look at algebraic expressions, right?
Yes, ma'am.
So now what we're going to do is, all right, let's take the example of something which is like 10x to the power, let's say 8. I'm sorry, 10x to the power 8 minus 5x to the power 3 plus 9x square. Okay, let's not square, let's make it something else. Let's make it 5 and plus 7. Okay, this is a polynomial. All right. Um let's take another example. minus 9y cube plus 1 by 4y. All right, that is another example of a polynomial. Another example of a polynomial could be pi a to the power, or let's not say a, let's say pi t square. Okay, and so on. We could also have something like 9s to the power 2, like 9s square minus 0.5 s to the power 4, or something like that. Okay, let's say. All right, so we have something like this. So these are all polynomials. And now, what is not a polynomial? If you have, if I take this, if I take the first polynomial, this one, and I just replace this with a minus sign. Okay, if I say 10x to the power minus 8 minus 5x cube plus 9x to the power 5 plus 7. So this is not a polynomial. Okay, this is not a polynomial. Why? Because over here we have a negative power of x. So what do you understand by this? We understand that in order for an algebraic expression to be a polynomial, the powers of each of these terms, right, we call them terms, has to be a whole number. Okay, it has to be a whole number. Yes, Mridula, you want to say something?
Ma'am, if the numbers are negative, ma'am, it will consider as polynomial or not?
You mean these numbers? These?
Yes, ma'am.
Yeah.
Yes, ma'am.
So it doesn't matter what these numbers are. By the way, these numbers that you were just referring to, these are called coefficients. Okay. So let me just let's take a look at it over here. So over here, this is a coefficient 10. It's called a coefficient. Okay. Over here, minus 5 is a coefficient. Over here 9 is a coefficient, and over here 7 is a coefficient. Okay, and you know, all of these separate um, things, these are called terms. What do I mean by that? This is one term. Basically, terms are divided, or they are separated by a plus or a minus. Okay, so and a polynomial, basically a polynomial will consist of, you can say it consists of a coefficient. All right, over here this is a coefficient, 9 is a coefficient, so it consists of a coefficient. It could be anything, right? Any number. A coefficient is any number. Like over here this is 1 by 4, no problem, it's a number. So that means coefficient can be any real number. All right, coefficient can be any just a sec, it can be any real number. But when we're talking about this thing, we're talking about the variable, right? We have a variable over here, and you have a power of that variable. Just a second. You have a variable, and there's an exponent on top of the variable. This exponent has to be a whole number. This exponent cannot be a negative number. It cannot be a fraction. So, you know, if I have something like 5x to the power 1 by 2, is this a polynomial? No, it is not a polynomial. Why? Because over here we have 1 by 2, which is a fraction, and fraction is not a whole number. So this is also not a polynomial. Okay. Uh, so basically, let's go to the unofficial definition of a polynomial. A polynomial is a sum of terms. All right, terms. And what are the terms? For example, take a look at this polynomial, okay? Minus 9y cube plus 1 by 4y. Over here, there are two terms. What are the terms over here? One term is minus 9y cubed and one term is 1 by 4y. And that's what we were talking about. Polynomials means many terms. All right, so this is a polynomial and this is also a polynomial in which there is only one term. That term is pi times t square. So this is called a monomial. You know, mono means one, right? Mono means one. So this is a polynomial in which there is only one term. That is why it is called a monomial. The second one, this one, it has two terms, so it is called a binomial. Okay, it has two terms. This one, the last one, it has three terms, so it is called a trinomial. And if something has more than three terms, then we just call it as a polynomial. Basically, all four of these are polynomials. But when you have only one term, it is a special type of polynomial, which is called a monomial. Two terms binomial and three terms trinomial. And more than that, it's a general term called, it's a general word that we use, which is called a polynomial. Okay. So let's just take a few examples and then you will understand what is a polynomial, what is not a polynomial. So how about 10 root x minus 15x square plus 3? Is this a polynomial, yes or no?
Yes, ma'am.
Okay, Mridula says yes. Hamna, what about you? What do you think? Hamna,
Yes, ma'am.
you think it is a polynomial?
No, ma'am.
Okay.
It's a
Yeah.
trinomial.
Okay. So when I say polynomial, it means that it should be of this type. Okay. There is a coefficient, there is a variable, and then there is a whole number, which is the exponent of that variable. Now, polynomials can be of different types, right? As I said, there are many types of polynomials. If you have only one term, then it is a special type of polynomial called monomial, right? So monomial is also a polynomial. A binomial is also a polynomial, and a trinomial is also a polynomial. You can't say that, oh, it's a trinomial, so it is not a polynomial. No. Just like, we say that if I show you a cat, and if I ask you, is it an animal? You will say, yes, it is an animal. Although it is a cat, it is also an animal, right? So similarly, every monomial, binomial, trinomial, they are also types of polynomials. So yeah, again, Hamna, would you like to, just a sec, would you like to change your answer on this one? Is it a polynomial?
Yes, ma'am. It's a polynomial.
Okay. Now, once again, take a look at what we defined a polynomial to be. We said a polynomial will be an expression of the form where you have a coefficient, okay? Basically, there will be many terms, all right? Let's say this is one term that we're talking about. You have a variable, it can be anything, it can be x, it can be y, t, z, anything. Then this variable has a coefficient next to it, and this coefficient will be a, what will it be? What can it be? We just discussed it. The coefficient will be,
Ma'am, whole number.
no, take a look at it carefully, take a look at this. Coefficient will be, okay, see here, coefficient will be,
Real number.
yes, coefficient will be a real number. Okay, so the coefficient can be any real number, but the exponent that we have over here, right? The exponent that we have over here, it has to be a whole number. Now take a look at this polynomial again and tell me if every single term of this polynomial holds true for this. Yes? Yes, Mridula? I can't hear you.
Ma'am, I'm not
Yeah?
sure about my.
Okay, you're
Ma'am,
not
I'm
sure.
not
It's
sure
okay.
about
No
my.
problem. But just give any answer. It doesn't matter if it is right or wrong. Yeah.
Yes, this applies.
All right. Take a look at this. Okay. Take a look at this. Can I rewrite this as 10 into x to the power 1 by 2? Can I rewrite it like this?
Yes, ma'am.
Yes. Okay. Now tell me, is this still a polynomial? Hamna?
No, ma'am.
Yeah, it is not a polynomial, right? So this is not a polynomial. Mridula, why is this not a polynomial?
Ma'am, because 1 by 2 is not a whole number.
Exactly. Right. So over here, in any of the terms, the coefficient of x cannot be a fraction and it cannot be a negative number. Okay. Sorry. Okay, um how about 5? Is this a polynomial?
Yes, ma'am. It's a polynomial.
Okay, Hamna, what do you think?
Yes, ma'am, it's a polynomial.
Why? How is it a polynomial?
Ma'am, because 5 is a real number.
Okay.
And ma'am, and the power of the 5 is 1. And ma'am, it's a whole number.
Okay, so you're not supposed to see the power of the coefficient. Okay. Hamna, would you like to say anything? Okay. See here. In any polynomial, a polynomial is basically, as you said, Mridula, it is an algebraic expression, right? And in an algebraic expression, we have two things. We have basically our whole algebraic expression, or let me just write it over here. Yeah, our algebraic expression or our polynomial is made up of different terms. Okay, let's say there's one term over here, one term over here, and one term over here. Now, each term will have two things. Each term will have two things. What will those be? It will have a coefficient, which is a constant number, which is a constant. What do you mean by constant? It means it is a number which does not change. Its value is fixed. For example, you have 5. 5 is a constant because 5 is always 5. Its value is never going to become 7 or it's never going to become 6, right? So every term has a coefficient and it has a variable. Okay, which is like we had, this was a constant and this is a variable. For example, you have 5x square. So x over here, x square or x, you can say x is a variable. So coming back over here, this term, this looks like it has only a constant. Where is the variable? Is there a variable over here? Yes,
Ma'am,
it doesn't have a variable. Hamna, what do you think? Yes.
No, ma'am, it does not have any variable.
Okay, how about take a look at this. If I write x to the power 0, what is this equal to?
ma'am, 1.
1. So now if I write 5 into 1, what is this equal to?
Ma'am, 5.
5. So can I write this? Can I write this as 5 into x to the power 0? Can I write it like this?
Yes, ma'am.
So now do you think it is a polynomial?
Yes, ma'am.
Yes. So it is a polynomial. What type of polynomial?
Ma'am, monomial.
Ma'am, binomial. No, ma'am,
It
monomial.
is a, yes, that's right. It is a monomial. Okay. Because this is a multiplication sign, not a plus. All right. How about um okay, 2 root okay 2 root 2 y square minus 5y cube. What about this? Is it a polynomial? I couldn't hear
No,
you.
no, ma'am.
Yes, Ranjit? Okay, Mridula is
No,
saying
ma'am,
yes.
no,
Hamna?
ma'am. Yes, ma'am. Yes, ma'am. Yes, ma'am. It's a
Okay.
polynomial.
Okay, Hamna, what about you?
No,
What do
ma'am.
you think? Okay. And why do you think so? Okay, so take a look at this. This is basically our coefficient, which is 2 root 2. This is our coefficient, okay? Then we have our variable y, and then we have the exponent of that variable, which is 2. And then we have the next term. The next term is minus 5y cube, right? So minus 5 is the coefficient, y is the variable over here, and then 3. This is the exponent. Now, Hamna, what do you think?
Ma'am, it's a polynomial.
It is a polynomial, right? Because when we take a look at the coefficient, we say, well, the coefficient just has to be a real number. It can be any real number. And we know that 2 root 2 is also a real number. Yes, it is irrational, but it is also, it is real, right? So this is a polynomial, okay. Um, now
Ma'am,
let's take a
ma'am,
look at, yes.
ma'am, in this type of equations,
Hmm.
ma'am, no matters what the coefficient is, na? Matters what is the variable.
Yes, exactly. We have to look at the variable and we have to look at the power of that variable. Okay. So just a sec. All right. Next, we take a look at um something which is like, yes, Hamna, you would like to say something?
Ma'am, any fractional number is a polynomial.
Any fractional number? Okay. How about you give me an example, Hamna?
Ma'am, 3 by 2.
3/2. That's it. Nothing else. Okay. So let's take a look at it like this. We have okay. So you said 3/2, right? 3/2. Now we can write this as 3/2 into x or y or anything, any variable, right? To the power of 0. And 0 is a whole number. 0 is a whole number. Check. 3 by 2 is a real number? Yes or no? Yes. Check. So it is a polynomial. Is that clear, Hamna?
Okay, ma'am.
All right. Now let's take a look at another example. How about 2.5? Yes, Mridula?
Ma'am, if the rational number is ma'am, the numerator and denominator both are no ma'am, numerator is in decimal form and denominator is in whole number form. So ma'am, it will be also be a polynomial.
Okay. Can you give me an example?
Ma'am, like as you written in the screen, ma'am, it's 2.5 upon 3, like that.
2.5 upon
And 2.
2. That's it? Nothing else?
Yes, ma'am. Yes,
Okay.
ma'am. Ma'am, that's it.
Okay, sorry. So 2.5 divided by 2. Now 2.5 divided by 2, is it a real number? Yes?
Yes, ma'am.
Yes, ma'am.
Yes, it is a real number, right? So you can write this as 2.5 by 2 into x to the power 0. So yes, this is a polynomial, right? Because 2.5 divided by 2 can also be written as 25 divided by 20, right? Because we took away this decimal, right? We took away this decimal. Basically, what we did was we multiplied the numerator and denominator by 10 so that we can get rid of this decimal and it shifts one place to the right. So we have 25 by 20 x to the power 0. So this over here is a real number and this also satisfies our checklist. So yes, this is a polynomial. Is it clear, Mridula?
Yes, ma'am.
Okay.
Ma'am, if the coefficient is irrational number, so ma'am, it will also be a polynomial.
Yes, yes. Just like we saw over here, root 2 is irrational, right? But it is still a polynomial. Why is it a polynomial? Because when you are checking for a polynomial, your checklist should be this, that your exponent, right? Your exponent should be a whole number and your coefficient should be a real number. And we know that real numbers are of two types. They could be rational, right? That like you have 1, 1.5, 2 by 3, and so on. Or it could be irrational, like we studied in the previous chapter, irrational, like pi, root 2, and so on, right? So yes, root 2, root 3 also get included in real numbers. So yes, that will be a polynomial. Is it clear?
Yes, ma'am.
Okay, cool. Now let's take a look at another example. If there's anything else you'd like to ask, you can ask away.
No, ma'am. Nothing else.
Okay. So 2.5 divided by 13x to the power minus 2 plus let's say 5x. 5x cube by x. Okay. How about this? Is this a polynomial?
Yes, ma'am, it's a polynomial.
Okay, Mridula says yes. How about you, Amna? What do you think?
Yes, ma'am.
Okay, yes, it is a polynomial. Why? Because we have 2.5 by 13 and then this x to the power minus 2, it is in the denominator. We can send it to the numerator and then this will become x square. So this term satisfies our criteria. Now the next thing is 5x cubed by x. This can also be written as 5x square. So this also satisfies our criteria. Okay. Now let's just take a look at some of the, just a sec. I'll just give you some questions. Give me a second. Okay. Now, before we move on, I'm just gonna share something with you, which is okay. So if we take a look at these previous examples, let's take a look at, I think this is becoming very shabby. So I'll just erase some things. Yeah. Now I want you to take a look at the first polynomial that we've written over here. Okay. Yeah, this one. So over here, how many terms do we have in this, Hamna?
Yes, ma'am.
How many terms do we have in the first polynomial?
4 terms.
4 terms. Can you name those 4 terms? Yeah. Yes, Hamna.
10, 10x raised to 8.
10x, yes, 10x is for 8. Then,
My
yes,
5x raised to 3.
minus 5x to the power 3. Yes,
9x raised to 5.
yes,
And 7.
and 7. Okay. Now, okay, what is the, okay, so when we have different terms, what happens is we talk about something which is called the term, the power of that term, okay, or the degree of that term. So I'm going to write it over here, degree of that term. So degree means to which power that term is raised. What is the power of that term? Okay. So the power of that term is basically the degree of that term. So Hamna, again, could you tell me the degree of this term? All of these terms? Yes. Mridula, could you do that?
Yes, ma'am. Ma'am, the degree of these polynomials are, ma'am, first is 8.
Hmm.
Ma'am, the second is 3.
Yeah, Mridula, it's not the degree of the polynomial. Right now, we're talking about the degree of the terms, right? We're talking about the degree of each of these individual terms. Okay, 3, and then the next one is 5. Hamna, what is the degree of the last one?
Ma'am, it's 1. And the last one is 1.
Hamna, what is the degree of the last term?
0, ma'am.
Yes, it is 0. Okay. Why? Because it is 7x to the power 0. Okay, Mridula? All right. Now, the thing is, there is something called degree of the polynomial. Okay. Degree of the polynomial. And that is, it's nothing too difficult. It's nothing too different. Degree of the polynomial basically means out of all of these degrees that you see over here, which is the highest? The highest over here is 8. So you will say that the degree of this polynomial is 8. Okay. So now, Mridula, what is the degree of the second polynomial? Hamna?
It's 3, ma'am.
Yes. And the next one?
2,
Very good. And then the next one?
4.
Very good. Okay. So now let's take a look at some questions. What's the time? Okay, we'll just take the class for 5 more minutes, okay? Because we started pretty late. I hope you guys don't mind. Okay. All right. Yes. The first question. Who would like to answer this? All right, let's take a look at each of these, okay? A.
Ma'am, A is a polynomial.
Just a second. I couldn't
Ma'am,
hear you
A,
clearly. Is A a
ma'am, A is
polynomial?
a polynomial. Yes, ma'am,
Really?
A is a polynomial.
Really, Mridula?
Yes,
Hamna, what do you
ma'am.
think?
Yes, ma'am.
Ma'am, B is a polynomial.
Okay. All right, let's take a look at this. All right. So we have the first one is x square by 2 minus 2 by x square. So, Mridula, x square by 2 minus 2 by x square. Let's just rewrite this. What is, okay, can we write this as x square by 2 minus 2 into x to the power minus 2? Yes. So this x square, it is right now, it is in the denominator. So it doesn't really count. This one, the 2 over here doesn't count when you're looking at the power or the exponent. So what you need to do, again, you need to come back to that definition where you have a coefficient, okay, or let me write it in small. You have a coefficient, which is a constant, real number. Then you have a variable, and then you have the power of that variable, and that power of that variable has to be a whole number. But over here, this is not a whole number. This is negative. So, Mridula, is it clear? This is not a polynomial. Okay?
Yes, ma'am.
Okay. Next, option B. So, Hamna is saying it's option B. Hamna, look carefully. Let me just zoom it in further for you. Look carefully. The root includes both 2 and x. The root is over both 2 and x. So, it's root over of 2x minus 1. So the power of x over here will be how much?
1 by 2.
Yes, the power will be 1 by 2. So, Hamna, now is it clear? This is not a polynomial. Okay?
Yes.
All right. Now let's take a look at option D. The D option. X minus 1 divided by x plus 1. Now, the condition that we had for a polynomial was that x should be in a positive power. But over here, x is in a negative power. Why? Because x is in the denominator. So this is again not a polynomial. Is it clear?
Yes, ma'am.
Okay. Now let's take a look at option C. X square. Just a sec. X square plus 3x to the power 3 by 2. So we have x square plus 3x to the power 3 by 2 divided by, what is it, divided by root x. So let's just rewrite this. Would anyone like to help me out in this one? How can we rewrite it?
Yes, ma'am.
Yeah.
Ma'am, x square plus
Hmm.
ma'am 3x raised to the power 3 by 2.
Hmm.
Ma'am, the root x comes over in ma'am, it will be the ma'am 3 into ma'am multiplied by ma'am 3x 3 by 2 multiplied by.
Okay. You're right, Mridula, you're going in the right direction. See, let's just take it step by step, okay? x to the power 3 by 2 as it is. Now I'm just going to focus on the denominator. This can be written as what, Mridula? This can be written as
Ma'am, x raised
x to
to
the
the
power 1 by 2.
power minus 1 by 2. Yes,
Yeah.
ma'am.
So right now, let's just keep it in the denominator. Okay. It is in the denominator. Let's keep it in the denominator only. So it's x to the power 1 by 2. Now, when we send it to the numerator, then it will become minus 1 by 2, right? So in the next step, we're going to do that. So x to the power 3 by 2. And then this thing from the denominator, it goes up. So this becomes into x to the power minus 1 by 2. Clear till here, Hamna, Mridula?
Yes, ma'am.
Yeah.
Yes,
So we have x square. This the whole thing is going to be the same. Now, if we take a look at this, we have it's basically x to the power a multiplied by x to the power b. So this becomes x to the power a minus b. Sorry, a plus b, right? Or another
Yes,
thing that
ma'am.
you could have done over here. So I'm just going to show you both the ways. This you can write this as x to the power 3 by 2 minus 1 by 2. Okay. This is also one way of doing it. Another way that you could have done it from over here was you could have said x square plus 3x. Now, this is, what is this? This is, you can say it is x to the power m by x to the power n. So it is x to the power 3 by 2. And this becomes x to the power m minus n, right? So just a sec. 3 by 2 minus 1 by 2. So you could have just skipped one step and done it from here as well, like Mridula was saying. So then we come to the same conclusion, x square plus 3x. And what is 3 by 2 minus 1 by 2, Hamna? It is 1, right? 3 by 2 minus 1 by 2 is 1. So we are left with x square plus 3x. Now, is this a polynomial?
Yes, ma'am.
Okay. So option C is the right option. And now we're running out of time. So the rest of the questions we will do in the next class. Are there any doubts in today's class?
No, ma'am.
no doubt, ma'am.
Okay. So let's take up the rest of the topic from the next lesson. All right. Thank you, class.
Okay, ma'am. Bye, ma'am. Good night.
Bye.
Good night, ma'am.
Bye. Good night.